This is Engineering Statistics and Linear Algebra 18 EC 44. We are in the second unit or module, which is multiple random variable. And the topic today is bivariate transformation. Till now we did the bivariate CDF and the PDF, and then the bivariate expectations we saw. And now we will take up the bivariate transformations, wherein we will transform the say two variables. Bivariate just means two variables x and y to another set of two variables, for example u and v. Now this transformation, whatever we take over here, is basically a linear transformation. We are not going to take a non-linear transformation. So once we say linear transformation, then the transformation will look something like this. That means x and y variables, the two different x and y variables are transformed into another two different variables, which are u and v, where u and v are related by u is equal to ax plus by and v is equal to cx plus dy. So if this is the relationship between the two variables uv and the two variables xy, okay, then what is the mean of this? So mean of this will be just expectation of this. Take expectation on all the sides. Then expectation of u will be equal to expectation of ax, that is a expectation of x, plus expectation of by, that is b expectation of y, and each of the expectation will be mu u, mu x, and mu y, and that's what we have here. Mu u is equal to a mu x plus b mu y. So expectation of a particular variable u will be its mean itself. Expectation of x is its mean. Expectation of y is also its mean. Similarly, for v equal to cx plus dy, the taking the expectation or mean on both sides will get mu y is equal to c mu x plus d mu y. When such is the case, then what will be the variance of the variable u, and what will be the variance of the variable v, and further what will be the covariance between the u and v in terms of the x and y is what we will try to see now. So variance of u is calculated as when I take sigma u square, which is the variance of u, then that is expectation of u minus mu u square. And what is u? U is ax plus by, and mu u is ax plus by, b mu y, a mu x plus b mu y. Okay, so we can substitute over here and write it like this. So u is ax plus by, which is written here. Mu u is a mu x plus b mu y, which is written over here because we have a minus term. We'll have both these terms as minus. Then we are trying to take the a common from this and this term. We'll get x into x minus mu a into x minus mu x plus b into y minus mu y. Whole squared is also there because this is the variance. So therefore, this squared term should be there continuously. Now, if you expand this, squared term a plus b squared, then we'll get a squared plus 2ab plus b squared. So a squared will be this quantity squared, which will be a squared x minus mu x whole squared. Then the quantity, 2ab, 2 into this will be 2ab x minus mu x into y minus mu y. Then this quantity squared will give us the b squared y minus mu y squared. Then we can take out this expectation inside for each one of this. Expectation of this x minus mu x whole squared will be nothing but the variance of x, that is sigma x squared. Similarly, whatever we have here, the expectation of these two terms over here, the expectation of these two terms over here will be the covariance of xy, 2ab remaining as it is. Similarly, expectation of this quantity y minus mu y squared will be sigma y squared, v squared remaining as it is. So this is the relationship 3.50, which is very much important, wherein we can say that the variance of u is represented in terms of the variance of x and y, where u is equal to ax plus by. U is equal to ax plus by. So with u is equal to ax plus by, the mean will be mu u is equal to a mu x plus b mu y, and the variance sigma u squared will be equal to a squared sigma x squared plus 2ab covariance xy plus b squared sigma y squared. In a similar way, we can say that because v is equal to cx plus dy, its mean will be mu y equal to c mu x plus d mu y. And the variance of v, which we can call it as sigma v squared, okay, sigma v squared, that will be equal to c square sigma x squared. In we have here c in place of a, so x as it is we have, so c squared sigma x squared plus 2cd covariance of xy plus d squared sigma y squared. Okay, so that is the only change which we will have. So sigma v squared will be whatever I have just spoken to you now, whereas that is c squared sigma x squared plus 2cd covariance xy plus d squared sigma y squared. Similarly, the covariance of u and v. Covariance of u and v is u and v have to be substituted from here, and then you separate it out. Okay, you separate it out, and then you can try to simplify. You'll get on the whole that the AC sigma x squared plus BC plus AD covariance xy plus BD sigma y squared. Okay, so that will be again the covariance of this will be just corresponding to expectation of u minus u minus mu x, v minus mu y. Both the terms are multiplied, and we can try to expand that, and we'll get this term totally. Okay, so that will be the covariance of uv, which we can see from the last chapter what we have written for the covariance, and we can try to expand it by substituting the value of u and v from over here, and try to expand and try to write over there, right? Okay, so here we are considering that x and y do not enter into the equations which we are writing over here, 3.50, 3.51 and 3.52. So 3.50 is here, 3.51 is here, and 3.52 is here. Okay, both these. Nowhere you have the mu term, the mean term there. Okay, mean term is there here, but in the variance you don't have the mean term. So that's what we are writing over here. Mean of x and y is not there on the right hand side of either of the three equations, 3.50, 3.51 and 3.52. Now let us take some examples corresponding to this. So in this example, what is given to us is zero mean random variable x and y. Zero mean random variable x and y means mu x equal to mu y is equal to 0. Okay, zero mean means mu x, mu y, both x and y variables, mu x and mu y equal to 0. And the variance is given for x as 7.0. Variance of y is given as 5.36. Okay, so mu x, mu y, both zeros. Sigma x squared 7.05, sigma y squared 5.36. So we are also given the correlation coefficient for x and y. So that is correlation coefficient is the rho xy equal to minus 0.48. This is negative value. Rho xy is minus 0.48. So do not get confused between sigma and rho. Rho is correlation coefficient, sigma squared is the variance, where sigma will be the standard deviation. Okay, so the bivariate random variables u and y are given with the transformation u is equal to 2x plus y and v is equal to x plus 2y. This is also given to us. So we have to find now the correlation coefficient, which is rho uv of the after the transformation. What will be the correlation coefficient? That is what we need to find out. So before finding the correlation coefficient, we need to find the covariance of the x and y. Okay, we need to calculate the covariance of x and y. So covariance of x and y will be equal to sigma x, sigma y, rho xy. Sigma x, sigma y are given to us. Okay, sigma x, sigma y are root of 7.05 and 5.36. 7.05 multiplied by 5.36, whatever you have, the root of that, and you need to multiply that with the value which is minus 0.48. So we will get the value minus 2.9507 for the covariance of x and y. So having found the covariance here, the variance of u and v have to be found out. So variance of u and v can be found out from the relation which is already given over here. Okay, so a squared sigma x squared plus 2ab covariance of xy plus b squared sigma y squared. So what is a and b? A is 2, b is 1. A is 2, b is 1, and the values of the sigma x squared is given 7.05. The what you call sigma y squared is 5.36. The covariance of x and y, we have found it as minus 2.9507. Okay, all these we need to substitute in this equation. So 2 squared, 7.05 squared plus 2 into root of 2 into 2 into 1, b is 1. Covariance is, we have just find out to be minus 2.9 something, plus b squared is 1 squared itself. Sigma y squared is the value which is given as 5.36. Okay, so substituting all that, you'll get 21.7572. Similarly, the sigma v squared can be found out from the relationship which is given over here, which is 3.51. So now c squared, if you see over here, c is 1, d is 2. So therefore, we need to write here, 1 into 7.05 squared plus 2 into, 1 into 2. Covariance of xy is again minus 2.9507. And then you have d squared, which is 2 squared. Sigma y squared is, basically the value which is given as 5.36. So if you substitute all that, you'll get 16.6872. Similarly, the covariance of u and v can be found from the relationship which is given here as 3.52 by substituting a value, c value, sigma x squared value, b value, c value, a value, d value, and then the value of the covariance xy which you have calculated as minus 2.95. Then the value of b and d can be substituted and sigma y squared can be written over here. Okay, so thus we can find the value of the covariance of uv to be 10.0665. So from all these values, you can try to find out the rho uv. Rho uv will be in the same way as we have found from here. The covariance of xy is equal to sigma x, sigma y, rho xy. That is, sigma xy will be equal to covariance xy divided by sigma x, sigma y. So therefore, rho uv will be covariance of uv divided by sigma u, sigma v. That is literally 10.0665 divided by root of the two quantities, which is 21 and 16. Then we'll get a value which is here 0.5283. So this result is interpreted to say that u and v now have a positive correlation coefficient. Okay, positive correlation coefficient of 0.5283, whereas the original xy variables had a negative coefficient. Even though the original xy variables has a negative coefficient, after the transformation, there's a good chance that whatever we get might be having a positive correlation coefficient for u as well as v. So now what we have here is, in place of a and b, we have taken cos theta and sin theta. Similarly, in place of c and d, we have taken sine theta and cos theta. Or rather, in place of A and B, we have taken cos theta and minus sine theta. In place of C and D, we have taken sine theta and cos theta, which is basically, rotational transformation, which is basically rotational transformation. So you compare this with the, value here, over here, u is equal to ax plus by and v is equal to cx plus dy. You compare with what we have written here, u is equal to cos theta minus sine theta y and v is equal to sine theta x plus cos theta y. It's very clear that we have taken a is equal to cos theta, b is equal to minus sine theta, c is equal to sine theta, d is equal to cos theta. So, and that will refer to basically rotational transformation. Okay, that will refer to basically rotational transformation, because you have a what you call cos theta into x. Cos theta into x is just the x component of the capital value x. Then similarly, y component of the capital value y is what we have here. So we are subtracting one from the other. Later we have the y component of x and x component of y, both are added together. That is basically rotational transformation. Now, if you rearrange this, that means these are two simultaneous equations. So if you solve these two simultaneous equations, okay, so that just means you multiply this by means of the cos theta, and this you multiply by means of the sine theta and add both of them, right? Then you will get as x equal to cos theta u plus sine theta v. Okay, you will get x is equal to cos theta u plus sine theta v. Similarly, you need to solve these two equations to get the value of y also. That means you need to multiply with a different variable, which is minus sine theta over here and cos theta over here. Then subtracting or adding both the quantities, you will get y is equal to minus sine theta u plus cos theta v. Okay, it's just solving of the simultaneous equations to find the values of x and y. So you'll get x and y like this. Having found x and y, we can find the mean for the x and y as given x, we have found x over here. Mean of x will be equal to cos theta mu u plus sine theta mu v. Similarly, the mu y is equal to minus sine theta mu u plus cos theta mu v. That's what we have got over here. Now, going on the same lines, we can try to find, from 3.50, 3.51, 3.52, which are given over here. 3.50 is given over here. So we know A is cos theta, B is, minus sine theta, substitute all that. Okay. Then similarly, C is, cos theta, D is sine theta. From what we have, C is sine theta, D is cos theta, A is cos theta, and B is minus sine theta. You substitute all that in this what we call equations 3.50, 51, 52. You are going to get the equations like this. Sigma x squared is equal to cos squared theta, sigma u squared plus 2 sine theta cos theta, covariance uv plus sine squared theta, sigma v squared. Similarly, the sigma y squared will be this quantity over here. Okay, you are just trying to substitute in 3.50, 3.51, and also in 3.52. If you substitute, you'll get covariance of xy is equal to sine theta cos theta, sigma v squared minus sigma u squared plus cos squared theta minus sine squared theta, covariance uv. Now this is basically cos 2 theta, and this is what we call, this quantity is nothing but cos 2 theta, and this is nothing but twice of sine theta cos theta is sine 2 theta. So this will be sine 2 theta by 2. Okay, this will be sine 2 theta by 2, and this will be cos 2 theta. Okay, this will be cos 2 theta. So now, if the covariance of xy, if we say that xy are uncorrelated, okay, that means, if we get a value 0 over here, then you can rearrange these two terms and we will get the value of theta. So suppose that we have the bivariate random variable u and v with the known expected values mu u, mu v, mu, sigma u squared, sigma y squared, and covariance u of uv. We are looking for a method to transform u and v into random variables that are uncorrelated. So you can say that covariance of xy is 0. If we consider the covariance of xy as 0, that is, if you consider this equal to 0, then you can take this on this side and keep this on the other side itself. Okay, so and we can consider the value of cos squared theta minus sin squared theta is cos 2 theta, 2 sin theta cos theta sin 2 theta. Then naturally, taking rearranging the words, that means basically, this is sin 2 theta by 2 and this is cos 2 theta. Okay, so taking this on that side, you'll get the value as minus sin 2 theta by 2 sigma v squared minus uh, mu squared plus cos 2 theta covariance of uv. So cos 2 theta if you take on that side, and the rest of the terms which are there, sigma v squared minus sigma u squared with a minus term on the right hand side downwards, then you'll get sin 2 theta by cos 2 theta. Sin 2 theta by cos 2 theta will be nothing but tan 2 theta. Okay, tan 2 theta. So you'll get tan 2 theta, and if you take the other terms on the other side, you'll get 2 of cos of uv by sigma u squared minus sigma v squared. So if we say that the x and y variables are uncorrelated, that is covariance is between x and y is 0, then we'll get tan theta is equal to 2 covariance of uv divided by sigma u squared minus sigma y squared. So knowing theta, the other parameters necessary to specify the uncorrelated x and y can be calculated with the equations 3.57 through 3.60. So whatever we have here, 3.57, from here, all these equations we can use and try to find out the different quantities over here. There is nothing to find out from here because already we have said the covariance of xy is equal to 0. So the only thing which we need to find out will be the value, theta initially, which is got from the 3.61, that is basically 3.62. Okay, theta we can find and substitute in the equations corresponding to 3.57, 3.58, 3.59, and 3.60 to find the value of mu x, mu y, sigma x squared, sigma y squared. So let us see an example corresponding to this. So it is required to have the correlated bivariate random variables u and v such that their mean is 0. Mean is 0 here, and the variance of each one of them is given to us. The correlation coefficient is also given to us. Okay, so given this, we can try to find out the covariance of uv. Covariance of uv will be nothing but what you call rho uv multiplied by root of 1 and 7. Okay, root of this and root of this. So basically it means this quantity multiplied by this will be the covariance. Okay, multiplied by only sigma u, sigma y. So covariance of uv is sigma u, sigma y, rho uv. Okay, and that will be rho uv is 0.30 multiplied by root of 1 into 7, and that will give us the value minus 0.7937. It is not 1 and 7 we should multiply. 1 and 7 you should multiply, but take the root of that. Multiply with this value. You will get the value which is covariance of u and v. So having found out the covariance of u and v, we can try to find the value of theta by using the formula which is written over here. Tan 2 theta is equal to twice of cos of uv divided by sigma u squared minus sigma v squared. Please remember that it depends upon what you write. If you write it in, if you keep your calculator in radians, it will give you the value of theta in radians. If you put the calculator in terms of degrees, it will give you the value of theta in degrees. Sometimes we make mistakes of getting confused that what we get degrees, whereas we have put our calculator in radians. Default, always the calculator will be in radians if you specifically turn it into degrees, then it'll show a reading in degrees. Okay, otherwise by default it will be in radians. You need to convert that into degrees by proper formula, that is 180 by pi, or otherwise put the calculator itself in degrees and find out the value of theta by using that formula. Okay, twice of covariance of uv divided by sigma u sigma v sigma u squared minus sigma v squared is what we need to use to find out tan 2 theta, and 2 theta will be tan inverse of that quantity, tan inverse of that quantity, which will give you this. If you set your calculator in degrees, if you set your calculator in radians, you have to multiply it by 180 by pi. Radians multiplied by 180 divided by pi will give us the value of the degrees. Then having found theta, we can use 3.57 and 3.58 and 3.59 and 3.60. These four formulas we should use to find the mu x, mu y, sigma x squared, sigma y squared. So sigma x squared will be equal to the using 3.57 and 3.58, we will get over here, we know that mu u, mu v both are zeros. We are given that mu u, mu v is equal to 0. So therefore, mu x and mu y also will be both zeros. Further, the what you call variance of sigma x squared and sigma y squared has to be found out using those formulas. And if you find that, we will get this quantity. Sigma x squared is equal to 0.8968. Sigma y squared is equal to 7.1032. Then, we can go for the next problem. However, we are left with only 3 minutes. The same way, we have the problem number 26 over here. We have a zero mean bivariate random variable x1, x2, that is mu x1, mu x2 both will be equal to 0 with their variances sigma x1 squared 2, sigma x2 squared 4. Variance of x1 is sigma x squared, variance of x2 is sigma x2 squared. So this is sigma x1 squared, this is sigma x2 squared, that will be 2 and 4. So sigma x itself x1 itself will be root 2, sigma x2 will be equal to root 4, that is 2. Okay, so their correlation coefficient, that is here rho of x1, x2 will be equal to 0.8. Random variables x and x1, y1, y2 are obtained from the equations which are written over here. Y1 equal to 3x1 plus 4x2, y2 is equal to minus x1 plus 2x2. Find the values of variance of y1, variance of y2, covariance of y1, y2. So because we have the mean of x1, x2 are as the what you call zeros, the mean of y1, y2 will again be zeros because of the simple formula that we have over here, which corresponds to the 3.57 and 3.58. Okay, so from there we can just take out over here. From there we can take out over here, and using those we can try to find out the quantities. However, I think this is not rotational, but we need to take out from the values which are considered over here. So in the same way as that. So that just means that covariance of x1, x2 will be 0.8 into root 2 into root 4, and that value is what we have over here, and that is 2.2627. Then using the 3.50, 3.51 and 3.52, which are three different equations which are here, this equation, and this equation here, we can try to find out the values of the what you call sigma y1 squared, sigma y2 squared, covariance of y1, y2. Please remember that earlier we had x and y, but now we have x